sometimes useful or preferable to have a parameterization that goes between t equals 0 or 1. It's going to happen for a lot of reasons. So I'm just going to take a moment here to expose you to this. So think about, to motivate this, just think about what this thing looks like as a line. So we're going from 1, 7 to 5 minus 2. So I can graph things maybe something like this. So we've got 1, 7 over to 5 minus 2. 5 minus 2, and there's 1, 7. And, line segment connecting those two. Actually, let's put those endpoints in blue as well, I suppose. Oops. Okay, so from 1, 7 down to 5 minus 2. Now the parameterization could go either forward or backwards like we saw before. So let's say we want a parameterization to go this direction. Really all that amounts to is maybe saying, let's call this one x1, y1, and let's call this one x2, y2. And then all the formulas that I write out, you could follow the same pattern, just using that order. Initial point, right? That's what this would be called, right? Is the initial point. And this is the terminal point. Okay. So what exactly has to happen if we just move from one point to the other? Well, obviously the x coordinates are going to have to increase from 1 to 5, right? So as t increases from 0 to 1, our x increases from 1 to 5. So basically, just pick f of t in order to do this. Pick x equal to f of t so that this happens. And the simplest way of doing this, actually gave you an example of in the first problem right here, when we were doing this bottom situation right here. Right, I said, let's have t go from 0 to 1 and get that guy right there, right? So let's take a look at doing that right now. So if I want t to go from 0 to 1 and x to go from 1 to 5, then this is what we're looking at happening. There's x, there's t, there's 0, there's 1, and we're going from 1 to 5. So my line segment that I'm thinking of is this one right here, and we can make that happen with x equal to, so my slope there will be 4, and my y-intercept is 1. Okay, and that's what I've drawn in the picture right there. And in the same way, we want y values to do the same thing. So as t increases from 0 to 1, y increases from 1 to 5. No, from, it's like decreases, pardon me, decreases from 7 to minus 2. Okay, and so we're going to also make y equal to g of t. So this happens, and That means we're going to want a line segment that is doing the same sort of thing. So as if we graph from t equals 0 to t equals 1, and we graph y versus that, we want it to go from 7 down to -2. So let's put a -2 down here. And yeah, what does the parameterization for that line look like now? Or what does a formula for that line look like? So yeah, let's go ahead and say that y equal to, my slope there will need to be a negative, and we're dropping by 9 units. So -9t, and my y-intercept is 7. So it looks like that. And yeah, so both of these guys together, let's go ahead and sort of underline these here. This is what we're looking for. Oh, I guess I should say my range of t-values here. Okay, and so my answer would be to let x, y be equal to 4t plus 1, comma, minus 9t plus 7 for a range of t values, parameter values from 0 to 1.